Let's get started. I would like to introduce KYZEN's own Scott Cain.
Thank you, Sherry. And good morning, everyone. And thanks for spending a few minutes of your time with me. Hopefully, you got a nice cup of coffee or something hot waking you up this morning while we spend some few minutes together. So, what we're going to be talking about is the remanufacturing cleaning of aluminum. Now, if you're looking for the remanufacturing of steel, you're on the wrong flight. We did that about 2 weeks ago. Eric Bromley did, and that's available on our Tech to Tech website. So you can go back and look at that. But today we're really going to focus on aluminum, and we're going to be looking at the best practices for the application. So we're going to learn a little bit about what the application is, the history, the things to look out for, what we're cleaning, and the best practices. So if it's implemented, you're going to have a smooth transition. So let's start with what is remanufacturing. Really, it's the rebuilding of a product to the original manufacturer's specifications, and that's using a combination of reused, repaired, and new parts. It can include a multitude of metals. We talked about steel. This is going to be about aluminum. You may see brass, and that may be in vision, home defense, aerospace, and automotive. That's really kind of where we're going to focus today is just those two portions with aluminum in the automotive sector. So let's take a look at what was going on in the past and some of the problems that caused kind of a reevaluation of this process. So historically, it was remanufactured engine blocks, gearheads, other automotive parts that are it usually burned on with some burnt on residue, some oil, some dirt, greases, environmental residues, etc. They were looking to use one chemistry, and there were some logistical issues and pricing that prompted them to look for an alternative. So what is the outcome of the alternative that they're looking for? They want to clean effectively using a single product, but definitely want to extend that bath life, make the money that they're spending on chemistry last longer, and eliminate or reduce the expensive and time-consuming media blasting to remove the smut. Now, it's a very manual process. It was taking a lot of time, and can we remove that so that money is not being spent? So let's talk a little bit about what is actually being remanufactured in the automotive sector. You can see it's the motors, transmissions, alternators, the starters, the pumps, brakes, fuel systems, and then the electrical. A quick note about the electrical, that may involve rewinding of motors, or it may be more on our PCB side of our business. And if you are doing that, we'd be happy to discuss that as well with you for chemistries, for kind of remanufacturing on circuit boards, re-cleaning those. So why do customers want to remanufacture their parts? First off, being able to save parts is definitely more cost effective than machining the new parts. They're already to tolerance, they're already to spec. They just need to be cleaned and kind of remanufactured back to that the expected look. And then the footprint on the environment is much less. If you think about all the things that go into new assembly, including the raw material, some things going to landfill, the manufacturing that leads to air pollution and other things that your EHS team is worried about. The remanufacturing is much better for the environment, and that's really a focus that we should all be looking at. And finally, with the right process, the lead time to remanufacture these parts is actually shorter than manufacturing new parts. So what are some of the considerations, kind of, if we're going to take these steps, what are the things we need to look out for? First off, is it a single or a multi-metal assembly? Is it just aluminum, or has it got some steel? Has it got some brass? What's the assembly look like, and what do we need to worry about in terms of chemistries for that? What are the environmental concerns? We want to make sure that we're protecting the environment, following all of our EHS standards. So what are the local municipalities telling us, and how do we make sure that everything is in alignment with that? What's the construction of the parts? How will fluid flow through? Where are we worried about blind holes or fine pitch threads, or something that we're not going to be able to get into, or we're going to have to make sure when we place the parts inside of the machine that we can get them flushed out? What kind of machine is being utilized? Are we purchasing a new machine, or are we utilizing what we have? Is that a spray and air, ultrasonics, agitation, et cetera, et cetera? And then what's on the parts? Is it oil? Is it grease, dirt, the environmental residues that come from the machine, the part being out in the general public being used, or what do we know what those are? And then what are the concerns of cleaning? Obviously, first and foremost, does it completely clean? That's the goal. Make sure we're able to get this completely clean. Will there be any corrosion? Are we worried about corrosion? We need to have corrosion as part of a corrosion inhibitor as part of the chemistry process. And how long is that supposed to last out in the field? All these type of things about your application are important to know. What damage could happen to the surface? Are we worried about any sort of pitting or etching based off of the chemistry and what the composition of the part is? And then is there a chance of oil and grease being trapped? That's kind of what we talked about with the through holes in the small parts. And we also want to make sure that if we're pulling the oil and grease off, we don't want to replace it. We don't want to put it back down on there. We want to get it completely out of the apple. So this is a traditional, typical cleaning process for aluminum. So, um, so as you can see, the part comes in on the left-hand side. It's going to go to a wash initially. That's usually a spray or immersion, and that's going to remove the oils, the grease, and the carbons that are in it. Then we're going to take that into a rinse cycle. We're going to rinse that chemistry and all that contamination off. And then we're going to go back into a wash. This is either an immersion or an ultrasonic. A lot of people standardize on an ultrasonic there. Is the removal of oxide and carbons in that wash. And then finally, we're going to rinse it off, but we're also going to rinse with a rust preventative product on there. That's the M6353. And we'll walk through each of your applications with you to make sure these numbers for the chemistry are the correct one. But these are just the ones that we're using for this example that we've laid out. So what are the keys to success? What are the things that are going to make sure that we have a really good process? The first is to make sure that the chemistry and the application are the best match. For example, steel will have a higher pH for the burnt on carbons, but the problem is that's going to discolor and etch aluminum processes. So let's have those conversations about what you're looking to do, what your materials are, make sure that the best chemistry is being provided for that. Second is to take the time to optimize the process. There's a lot of different variables in there, whether it's temperature or filtration or chemistry or concentration or water quality or rinse, et cetera, et cetera. Let's make sure when we're implementing the process that we optimize, make sure that we've got the time, temperature, everything right, and we're utilizing the chemistry to the best of our ability. So then if something changes, we know what it is because we know what those standards are. Confirm that the rinse is clean. Just like when you're cleaning off your spaghetti plates, if you're rinsing with dirty water, you're not going to get those clean. It's the same concept. We want to make sure that that rinse is being cleaned, and along with that, that the filtration system is being used. We don't want to redeposit any of the oils and grease and the burnt on carbons back onto the parts. We want to make sure that once we're washing that off, that's getting out, and make sure that the temperature is in alignment with the manufacturer's suggested temperatures. There's a range where the chemistries work really well, and there's a range where the chemistries don't work as well. So we want to make sure we're staying within that sweet spot. Additionally, answer if the chemistry has corrosion protection, and if the application requires it. What are the requirements for corrosion protection? What does the chemistry have? Let's make sure everything's in alignment with what you're looking for, so how long those parts are sitting there, we're not going to have any of those problems. Once the process is dialed in, make sure to control that process. Do your PMs, make sure that your concentration is in place, your temperature is in place, your filtration system is working how you want it to work, et cetera, et cetera. So we make sure that we're staying right where everything's working well. There's a lot of variables, so if one gets out of control, it's really easy to come back and find that one. But if we're not paying attention, multiples can get out of control, and then it becomes really hard and time consuming. And finally, work with your safety team with regards to any sort of environmental concerns. Utilize that ally that you have, understand what their local municipalities require, and make sure that we're falling in alignment with those. So, remanufacturing in the automotive sector, you can see these dirty parts on the left. Let's send them through the right process with the right machine and the right chemistry, and then we have what comes out on the right. And so just kind of in closing, cleaning your remanufactured aluminum parts can provide significant savings, um, and it provides a lot of environmental uh, attributes. We're going to help the environment, and so that's a beautiful thing for all of us and our grandchildren. And then just to let working with your local Kaizen representative can assure a smooth transition and process confirmation. We've got labs all over the world, and we've got personnel all over the world. Kind of, we can use the library of information that we have, the experiences, the history of applications that we have to kind of send you on the right path and to have those conversations to get you where you want to go, so you're not having to flop around without knowing what's going on. We can help you with that. And finally, I just want to let you guys know, if this was interesting, in 2 weeks, a coworker of mine, Ethan Mueller, will be doing a conversation in the same format, the same time frame, about remanufacturing and rust and how do I avoid it. And I highly advise you taking a couple minutes to spend with Ethan. So I hope you guys, your coffee's still warm. We're trying to keep it short, and I really appreciate you taking a couple minutes and hanging out with us on this Thursday morning.
Great. Thanks so much, Scott. If you would like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.